Now we want to have a look on the mechanisms for each of the reaction that involve in benzene reaction. The first reaction we have here is halogenation that involve the electrophilic substitution reaction. We have bromination of benzene, for example here. There are three steps of the reaction that involve in order to come up with the final product. So for the step 1 is activation of Lewis acid. There will be polarization of the weak electrophile, which is bromine, with catalyst FeBr3. And after polarization, the polarized bromine will act as a strong electrophile. Then, for the second step, the electrophile will be attacked by the benzene ring. We know that benzene ring has reach of electron, whereby electron being localized in the ring. So it will act as a nucleophile and will attack the site that have less electron density. Okay, then there will be formation of carbocation intermediate and FeBr4 anion. For the carbocation intermediate, there will be a resonance whereby the electron will move to the carbon that have less density of electron, which is the positive side of carbon, and the electron will keep moving, okay, until the third step that we have here is deprotonation. The deprotonation will take place when FeBr4 anion act as a nucleophile. It will protonate or remove this hydrogen, and this bond will break and electron will give back to the carbon that have um, positive side. So we'll get the product, electrophilic substitution product, and HBr plus regeneration of FeBr3 as a catalyst. For the mechanism of nitration reaction of benzene, the nitric acid accepts a proton from the sulfuric acid and then dissociates to form nitronium ion. This nitronium ion will act as an electrophile in the process, which further react with benzene to form an uranium ion. The uranium ion then loses its proton, okay, by deprotonation of its nucleophile, forming nitrobenzene. Sulfonation of benzene is a process of heating benzene with fuming sulfuric acids that consists H2SO4 plus SO3 to produce benzene sulfonic acids. The reaction is reversible in nature. Due to higher electronegativity, oxygen present in sulfuric acid will pull an electron toward itself, generating an electrophile. The reaction continues by the attack of benzene ring towards the electrophile, and there will be deprotonation by base, leading to formation of benzene sulfonic acids. The Friedel-Crafts alkylation reaction proceeds via a three-steps mechanism. For the step 1, the Lewis acids AlCl3 undergoes reaction with the alkyl halides, resulting the formation of electrophilic carbocation. For the second step, the aromatic ring, which acts as a nucleophile, it will attack the carbocation, forming an intermediate. The aromaticity of the arene is temporarily lost due to the breaking of the carbon-carbon double bond. For the step 3, the deprotonation of the intermediates leads to reformation of carbon-carbon double bond, restoring the aromaticity to the compound. This proton here goes to form hydrochloric acid, regenerating the AlCl3 catalyst. For the acylation of the aromatic rings, or the reaction also known as the Friedel-Crafts acylation, the Lewis acid AlCl3 will react with the acyl chloride, forming an acyl cation. The acyl cation being stabilized by the formation of resonance, and there are also formation of AlCl4 anion. Then for the second step, the benzene ring acts as a nucleophile, will attack the electrophile and forming an intermediate, and there will be a deprotonation of the proton by the anion, forming the final product, and there will be formation of HCl and a regenerating of AlCl3. Substituents can cause a compound to be more or less reactive than benzene. Substituents affect the orientation of the reaction, where the positional relationship is controlled. The substituent can be divided into 3 groups. The first one is ortho and para direction activators. Second, para directing deactivators, and the last one is meta directing deactivators. I would suggest if you can remember some of the species in each of the groups. I have included some of the examples on how to answer the question regarding the reaction of benzene, and also I've shown you the um, reaction pathway and the final products, and also I've also include in this slide the common mistakes that students always did in exam. Please go through all the example and common mistakes, and please do your own exercise in order to really understand on reaction of benzene.